Hello dear students, welcome back to NEET World. So this is our session 5 on aldehydes, ketones, carboxylic acid, right? So this session is exclusively for NEET, JEE and EAPCET students, okay? Right. So in the last sessions we have covered aldehydes, their chemical properties, ketones, their chemical properties, preparation methods, and what are the important things are there. We have discussed some Nemal reactions are also discussed, yeah. So we are also started discussing about carboxylic acids. So here today we will be discussing about chemical properties of carboxylic acids. Okay. Once after finishing this, there are a few more properties of carboxylic acid. Yeah. After completing them, we will be doing some previous year questions from NEET, JEE and EAPCET exams. Okay. Right. So just follow the session till the end. You will get complete clarity on this discussion. Okay. So now here one of the important property of this carboxylic acid is the chemical property. Okay. So now how can we explain this chemical property? Is very easy. See, organic acids, whether any of the organic acid if you take, those are generally considered to be weak acids. When I compare with inorganic acids, organic acids are weak acidic, okay, weakly acidic when we compare with the inorganic acid. For example, acetic acid I am considering with the HCl. So HCl is an inorganic acid. When it comes to carboxylic acetic acid is a carboxylic acid. See how I am defining carboxylic acid and inorganic acids. See, organic acids are those which contains carbon atom having OH. Okay, carbon atom with OH. It means carbon and its compounds are considered to be organic, right? So here organic acid is something like this. Carboxylic acids will be like this now. Yeah. So if this kind of groups are there, then we can say them as carboxylic acids, and these are examples for organic acids. Okay. Now since these are weak acidic, what happens is there exists a reversible condition or an equilibrium state, okay, at particular temperature between this undissociated molecule and the dissociated ion. That is, after releasing H plus ion, we are going to get a carboxylate ion, right? So now if this particular acid is more acidic, equilibrium moves forward, equilibrium shift more towards forward. A strong acid have, a strong organic acid have greater dissociation constant, greater Ka. So greater the Ka, greater is the H plus ion concentration, greater is its acidic nature, we can say. Okay. If this conjugate based format is highly stable, then equilibrium moves forward and that particular acid have more acidic nature. Okay. So now look at this, what they are saying. Carboxylic acids like alcohols react with active metals like sodium, potassium, lithium, all these metals will react with the carboxylic acids, liberates hydrogen gas. Okay. So now what they will do, since this acidic proton is there, those are highly reactive with this reactive metals like sodium, potassium, rubidium, all these things. Okay. Right. And what they will do, they will give you hydrogen gas. Okay. So similar to alcohols, alcohols also react with sodium metal, and you know even carboxylic acids are more acidic than alcohols and phenols. Okay, remember this statement. Okay, right. Now see, when I discussed about alcohols, there I told you alcohols does not react with sodium bicarbonate. What I told you, sodium bicarbonate, they won't, phenol and alcohol does not react with sodium bicarbonate. But when it comes to carboxylic acids, yeah, carboxylic acids react with sodium bicarbonate and releases CO2 gas. What they will release? CO2 gas from this bicarbonate, and water molecule is formed, and it will be forming respect to conjugate base. Okay. Now the question in the exam will not be like this. The question will be, which are the following is more acidic? So they will give you 4 carboxylic acid examples, like A will be given like this. Let us say acetic acid is given. Okay. And B will be formic acid. So they will compare this AB and they will ask us which is more acidic. Okay, which is more acidic, acidic nature they will ask, acidic nature order. Okay, which is more acidic they will ask. How can we decide this? Yeah, it's very simple. What I told you, so once if this is an acidic species, once after releasing H plus ion, what is the remaining species we have? Conjugate base we have, yeah. So the conjugate base formed here is like this, acetate ion and H plus ion, right? So if this acetate ion is more stable, then it will be more acidic. Now here also you can write this formic acid forms formate ion and H plus. So if formate ion is more stable than this acetate acid, then this equilibrium moves forward and I can say this acid is more acidic. Yeah, and remember here a conjugate base stability depends on what type of group attached here. See, this is an electron releasing group. Alkyl group is electron releasing group. Here we have just a hydrogen now. So due to this reason, what happens, already oxygen has negative charge, already high electron density is there. If this electron releasing also group also releasing some electrons towards this negative charge, now what happens, more electronic repulsions will be raised. So due to that, stability decreases. So now what type of groups increases the acidic nature of carboxylic acids? If there is any electron withdrawing group, acidic nature will be increased. Acidic nature will be increased. Acidic nature of carboxylic acids will be increased. Okay. So now here we have electron releasing group. There is no such group. Therefore I can say formic acid is more acidic than our normal acetic acid. Okay. So this is how you need to understand the concept. Okay. I hope the discussion is clear up to here. Right. If it is clear, just click on the follow button. If you are new to this channel and clear means you just click on the like button. Okay. Right. Right. The next one here I will be showing you few questions. CH3 COOH. Okay. CH2 F COOH. Okay. Let's do this question with halogens. Here it is chlorine, here it is bromine. Yeah. So out of these ABCDs, tell me which is more acidic, or write the order of acidic nature for them. So how can you write? See, here we have electron withdrawing group, that is minus I effect can be shown by this more electronegative fluorine atom. Therefore the negative charge, that electrons here will be dragging towards it and easily it will release as H plus ion. So which is more acidic here? Since more electronegative fluorine is there, yeah, this will be more acidic. After this, here we have chlorine, which is having more electronegative than bromine. Therefore this makes it to be more acidic than the remaining D. Okay. And between A and C, see here we have bromine, at least some electronegative group is there and it is purely electron releasing group only. So due to that reason you can write D and least is A. So this is how you can decide the final answer. I hope the discussion is clear. Right. Let's move forward. Yeah. See here what I am saying. Whenever there is electron withdrawing groups attached to the carboxylic acid, their acidic nature will be increased. Okay. What are the examples here I am giving you? CF3, NO2, CN, FClBr. These are some examples for electron withdrawing groups. Now see, based on this order we can make or we can expect some questions. See, I am writing a carboxylic acid here, to which the first case I am adding CF3, second case let us add NO2, and here writing cyanide. So which is more acidic, they will ask. How can we decide? Again, just now we discussed now. So if there is strong electron withdrawing group, it is more acidic. So strong electron withdrawing group as per the effect order here, experimental order. Therefore A will be more acidic than B, then least is C. So A, B, C. So this order is based on purely on this one, which is an experimental order. Okay, right. So now look at here, order of effect of electron donating group. So if electron releasing group or donating group is present, acidic nature decreases. Okay. So this is the more electron releasing group, tertiary butyl group, and the next isopropyl group, and ethyl, and least is methyl. Like this you can remember. So based on the previous question discussion, it means in the previous slide I have given fluoroacetic acid and chloroacetic acid, bromoacetic acid like monochloro, monobromo, bromo, monoiodol, like this I have given. So now see, since more electronegative fluorine is there, that's why it is more acidic than this chloro, and then bromo, and least is iodo. Okay, clear now? Right. right. And the next example, if you see here, this compound contains 3 chlorine like CCl3COOH, and here it contains 2 chlorines, and here it is 1, and here it is 1, and here also we have 1. Okay, so now what you can understand, as number of chlorines decreases, as electronegative groups or electron withdrawing groups decreases, their acidic nature also decreased if you check. Right now that is what we are observing here. So just ignore this molecule. Okay, yeah. So now just see what are the case. Yeah, here more electron withdrawing groups, more electronegative groups, 3 are there, here 2 are there, 1 is there. So as number of electronegative groups increases, see there is 0, here 1, here 2, here 3. So more the number of electron withdrawing groups or electronegative groups, more is the acidic nature. So like this. Okay, hope the discussion is clear. Right, let's move forward. Yeah, some reactions we will understand, and before that reactions, I just wanted to mention few more things here. Yeah, so listen this. Before this, till now we have discussed about aliphatic now. So let us see some aromatic examples also. What is the name of this compound? It is called as benzoic acid. What is it? It's a benzoic acid. Now on this benzoic acid, generally what we know, if any electron withdrawing group is present, it will be more acidic. So out of these 3, which is more acidic, tell me? B is more acidic than A, and least is C, because here electron withdrawing group is there, that will increase the stability of conjugate base formed releasing H plus ion. That's why it is more acidic. Okay, right. So now what I am doing, just see here. Here I am attaching one methyl group. We know methyl groups are electron releasing groups, but there is something to be noted here. Out of these 4 compounds, which is more acidic, they will ask. Okay, remember, always remember, in case of carboxylic acids, in case of aromatic carboxylic acids, on benzene ring, whether it can be electron releasing group or it can be electron withdrawing group. If that group is present at ortho position, what I am saying, whether it can be electron releasing group, electron withdrawing group. Normally what we have studied, if electron withdrawing group is present, then its acidic nature increases, whereas electron releasing group is present means acidic nature decreases. This is what we have studied. But here if you observe, alkyl group and this isopropyl group, and that is tertiary butyl group. So in this case, what we know, it is a stronger releasing group, means this should be least acidic, we might think. But here exceptionally D is more acidic. Why it is more acidic? This concept is called ortho effect. What I am going to discuss now, ortho effect. So yeah, so what is ortho effect here? Whenever a group at ortho position of this carboxylic acid, aromatic carboxylic acid is present, that will increases the acidic nature of the compounds. Why it will increases? See, actually there is something called cross conjugation between this carbon, this conjugate base formed like O minus after releasing H plus. Okay, see, generally if the conjugation is between same atoms, see, oxygen, oxygen, if the conjugation is in this way, if the conjugation is taking place between same atoms, then you should say it as an equivalent conjugation. What is that called? Equivalent conjugation. Okay, but you know, in aromatic rings what happens is, due to the pi electrons of this benzene, it will also interrupts in the resonance between these two equivalent conjugations. So that is what we can say, cross conjugation is taking place. So due to that cross conjugation, the stability of conjugate base is decreased. Okay, so in order to avoid this cross conjugation, we have to introduce some bulky groups at ortho position. Now what these bulky groups will do is, these bulky groups will pushes this carboxylate ion to out of the plane. So when it is pushing out of the plane, it will not involve in conjugation with the ring pi electrons. Okay, now it will be having only equivalent conjugation and there is no cross conjugation. Okay, so that's why greater the bulkier group attached at the ortho position, whether it can be releasing or withdrawing. If the bulky nature of that group is more, that will effectively pushes this carboxylate out of the plane and makes it to be more stabilized one. Therefore, the bulky group containing carboxylic acids at ortho position, bulky group containing aromatic carboxylic acids are highly acidic compared with the others. So I can say this is bulky group now, so more acidic D, and after that C, and between this C, this is a bulkier than this, so C, and this is B, because there is one methyl group and there is no such group. So B and least is A. So this concept is applicable only at what? Ortho position. If the same story, if you wanted to repeat it meta or para, it won't work. Only at ortho position it will work. That's why we have highlighted the name as ortho effect. What is this effect called? Ortho effect. Okay, remember this is important concept. Okay, yeah. Okay, so I hope the discussion is clear. Now let me explain you one more. Between 1 and 2, tell me. Yeah, again one only more acidic because it is causes ortho effect. I mean it will avoid the cross conjugation. But here this is at meta, there is no such interactions. Okay, there is no such interaction as we seen here. See, when it is an ortho position, there is repulsions here. Due to that, COOH goes out of the plane. Okay, that makes it to be more acidic. Okay, due to equivalent conjugation. But here cross conjugation is present, which makes it to be less acidic. So one is more acidic than 2. Like this we need to answer. Okay. Next, reactions involving cleavage of CO bond. So there are some reactions in which CO bond cleavage is taking place. Okay, right. The first reaction here is esterification. So what happens in esterification? See, you take 2 moles of carboxylic acids. Sorry, you just take carboxylic acid. Okay, treat this with alcohol. With what? Alcohol. Okay, and this reaction is a reversible reaction. Each step is having equal possibility to go forward and backward. Okay, so we can say it's following microscopic reversibility rule, and this happens in acidic medium. Okay, now what happens? The OH from carboxylic acid, H plus from alcohol will be removed. Okay, and it will be giving you ester. Okay, what it will be giving you? If this is R dash, so you are going to get a OR dash. Okay, an ester product is formed. Okay, that's it. Okay, this is what you need to know. Okay, now rate of the reaction, rate of this esterification reaction depends on these bulky groups. Okay, these bulky groups. Okay, if these alkyl groups are these alkyl groups are bulkier, rate of reaction is less. So rate of reaction is more if R groups, that is alkyl groups are smaller. Okay, that's it. Okay, it means either in alcohol or in carboxylic acid, if bulky groups are introduced, then its rate decreases. That's it. You can remember in this way. Okay, right. Now let me add one example here. Yes, tell me, what is the rate of this reaction, rate of acidification for these 4 examples? So how can you answer this? Based on our discussion, rate of reaction is more if bulk alkyl groups are smaller. So where do we have smaller alkyl group? Yeah, so there is no alkyl group here, just a hydrogen, no? So it will be undergoes acidification very easily. Okay, so A is more. After A, if you see, there is a methyl and here ethyl. So methyl is smaller than ethyl and ethyl is smaller than isopropyl. So therefore smaller all groups easier or greater will be the rate of reaction. So A, B, C, D. So this is a rate of reaction for acidification of this carboxylic acid. Even the same story valid with the alcohols also. So smaller the size of alcohol, greater is the rate of reaction in the acidification. Okay, right. So is this clear, guys? So whatever we have discussed, is this clear or not? Hope it is clear. Right, let's move forward. Yeah, so the next, formation of acid anhydride. So here you just take 2 moles of carboxylic acids or COOH. Okay, so we are taking 2 moles now, write them separately, RCOOH. If I write in this way, so these 2 moles of carboxylic acids, if we write in this way, now what happens here is, this one will provide hydrogen, other will provide hydroxide, removed as water. So what is the next remaining part? See, R, C double bond O, here oxygen attached to this carbonyl group carbon and R. So we are going to get a anhydride. We can say it is an acid anhydride. And you know, if you hydrolyze this, you are going to get your starting material. Means by removal of water, you will get acid anhydride. By addition of water, you are going to get your carboxylic acids. Okay, remember this. Okay, next, reactions involving carboxylic group, COOH. Okay, this is again important reactions now. So here particularly need to remember about decarboxylation reaction and coal-based electrolysis. These are 2 important reactions. Okay, let's look into them. Let's see what exactly it is. See, in decarboxylation reactions, what happens is carboxylic acids treated with soda lime. Soda lime means NaOH plus CaO. So this is what soda lime. Okay, so when we are treating this, what happens is this CO2 group is eliminated from the carboxylic acid. See what is eliminated? This CO2. Decarboxylation means removal of CO2. Okay, if we remove CO2, what is the part we have? One R and H. So the product formed here is RH. That's it. Okay, this is what happens. Okay, right. So now here I will tell you one simple way to identify the rate of reactions or which molecule will be readily involving these decarboxylation. This is how we can expect the questions. Okay, let me give you 2-3 examples more, then you will get more clarity. Yeah, what is this called? Acetic acid now. So acetic acid in decarboxylation, what happens, tell me? Remove the CO2 part, so you are going to get methyl hydrogen, that is methane now. So CH4 we are going to get. If you observe how many carbons are there in the first starting material, 2 carbons are there. So product has only 1 carbon, right? So it means the product formed will be having 1 carbon less than the starting material. So if the reactant has n number of carbons, product will be having n minus 1 number of carbons. Okay, you can make a statement. Decarboxylation of carboxylic acids gives alkanes. Okay, here Nc carbons converts into n minus 1c carbons. Okay, this is the change or transformation taking place. Okay, write in your notes, it will be useful. And the next I will be adding you few more questions, concepts here. Right, so see here what I am writing. Whenever we are doing decarboxylation, what happens, you know, this CO2 part is removed now. It means this carbon here will get a negative charge. What it is going to get? A negative charge right now. So negative charge is present means it's forming a carbon anion. Okay, like a transition or intermediate state, we are going to get a carbon anion. So we know carbon anions are more stabilized when there is electron withdrawing group. So I can make a statement, electron withdrawing group containing carboxylic acids are readily undergo or electron withdrawing group containing carboxylic acids have greater rate of reaction. So it means I will show you few examples. Tell me out of this. Here one electron releasing group is present. Here no such groups. Here we have electron withdrawing group. Now tell me what happens in these three cases. A, B, C, let us say. Yeah. So now what happens is, when you remove the CO2 part from here, you are going to get a negative charge here. So this negative charge can be stabilized by this withdrawing group in C case. Since it is stabilized with using this electron withdrawing group, so formation of carbon ion is easy, that is decarboxylation is easy here. Therefore I can say rate of reaction, the rate of decarboxylation will be more for C, and there is no such group here, but here releasing group is there. So its rate of reaction is least whenever there is releasing group in decarboxylation. Okay, so like this you need to write the answer. Okay, I hope the concept is clear again. Right, guys, if there is any confusion, feel free to mention. Okay, and the next here we have coal-based electrolysis. What is this coal-based electrolysis or coal electrolysis? Okay, it's easy. See what I am writing here, RCOOH. This is a carboxylic acids. Okay, what we will be doing is, we will be taking salt of this carboxylic acid. Salt of carboxylic acid means you just add to the carboxylic acid, you add base. Now what happens, let us say NaOH is added, sodium salts of carboxylate acid is formed. Okay, so these is subjected to Kolb's electrolysis. Now what happens is during this electrolysis we have something called anode and cathode. So at anode it has a positive terminal, so here oxidation takes place. What happens here? Oxidation takes place. So what is the, see, anode is a positive terminal now, so it will attract the negative part of this substrate. What is the negative part? Carboxylate ion. So this carboxylate ion, by passing this electricity, what happens? It will cleave, electrolysis, it will do breaking of this negative charge, that is electrons, and gives you a radical generation. Okay, so provides a radical like this, one electron is removed. So when it is giving a radical, radicals are highly reactive, therefore what it will do is, see, radical having one electron and it utilizes one more electron from this bond. Okay, out of this two electron, one electron is used to make a pair and forms, see, double bond O, double bond O. CO2 gas is formed here. Okay, so what is released? CO2 gas is released. And what is the other part here? We have R radical, right? So these R radical will combine themselves. For example, if I am taking 2 moles of carboxylic acid, you will get 2 moles of carboxylate salt and it will be giving you 2 R radicals, right? So these 2 R radicals combine with themselves and form RR type of product. I will tell you one tricky way. Anyways, this is the mechanism. So where our product is forming, alkane is formed at anode. CO2 gas is also released at anode. Now what happens at cathode? See, we are taking the salt solution of this carboxylate ion. So sodium ion will remain as unipositive charge only, but water aqueous solution we are taking now. So from this water, H plus ion converts into H2. So what happens? H plus ion converts into H2. So this happens at a cathode. Remember, reduction takes place at cathode. Okay, oxidation taking place is anode. So what are the oxidized products here? Are oxidation products here are anode reaction, anode electrode put in anode electrode products. What are they? Alkane, hydrocarbon, higher alkane, and also CO2 gas is formed at anode and H2 gas is released at cathode. This is what you need to mention in the exam, or you need to know the answers. Okay, right. Is this clear? Guys, is this clear? Yeah, if it is clear, click on the like button. Yeah. Then next here, these are the things we can expect a direct question in NEET, JEE and EAPCET. Even in EAPCET also, if there is a question asking about products formed at anode and cathode during the electrolysis of carboxylic acids. Okay, like they will give you electrolysis of sodium acetate gives following products at anode and cathode. They will give 4 possible options. Okay, but one option is perfect out of this 4 right now. So that's how they will make the question. I hope you got the concept, right? So now what makes the difference between decarboxylation and Kolbe's electrolysis here? For example, this is the carboxylic acid we are taking. So upon decarboxylation, that is treating with CaO plus NaOH, okay, soda lime, what it will be giving you? So it will be giving you RH type of product, alkane is produced. But if you do Kolbe's electrolysis gives you RR type of product, okay. So it means this alkyl group is doubled during Kolbe's electrolysis, but in decarboxylation reaction just forming RH type of product, okay. So R and H alkane. For example, if it is a propanoic acid, what I am saying, propanoic acid contains 3 carbons, okay. So propanoic acid means 3 carbons. Now what happens? One carbon is carboxylic acid, so alkyl group is ethyl now. So now what happens? Ethyl and hydrogen forms ethane gas, okay. Ethane gas is released when you decarboxylate the propanoic acid. And what is the product formed during the Kolbe's electrolysis for that propanoic acid? Okay, so what is our alkyl group here? Ethyl, no? So ethyl and ethyl forms butane, because 2 ethyl groups means 2 carbons, okay. So it will make a 4 carbon chain. So that is nothing but butane is produced, okay. Right, the discussion is clear now, right? Guys, if it is clear, again click on the like button. Yeah. So the next, distillation of calcium salts. So what is this distillation of calcium salts means here? Yeah, just see here, calcium formate if you take, it will giving you formaldehyde. So what happening here? Calcium formate. See, calcium will be +2 charge and our formic acid, like for example, you just see here, formic acid we have, let us say, and calcium metal we have. So what it will do? See, it's a divalent, but it's a monovalent, like only -1 charge is there now. So like this, okay, but calcium is +2. So in order to balance this, we require this formate ions 2 and hydrogen gas you can write, okay. So now what I am discussing, I am not discussing about all these things, just I want a calcium salt here, okay. So this is what the calcium salt, okay. So calcium formate I can say, okay. This calcium formate, upon heating, what happens is this Ca and here CO is there now. So just write them separately, CO, O minus, H, CO, O minus and Ca plus 2. Now just see here, upon heating what happens is this calcium and carbonate, CaCO3, like this it is removed. Now what are the remaining part, tell me? HCO, HCOH. So formaldehyde is produced. When you heat calcium formate, what we are going to get? Formaldehyde will be the product, okay. This is the distillation product, okay. Now when you are doing calcium formate plus calcium acetate, so what we are having? Acetate we have and formate we have, okay. So now what to do? Heat this, so it will be removing the CO2 and H2. So remaining part will be this one. So what is the remaining part? CH3, COH. So acetaldehyde is produced here, okay. Calcium acetone gives like calcium acetate gives, only pure calcium acetate gives acetone. Okay, that's it. Here we have examples to be understood. Okay, the next page also I have few more examples. Yeah, see here calcium formate, calcium propionate we already discussed. Okay, and if you see calcium acetate plus calcium propionate, so what we need to do, just remove CO3 part from here and gives you CH3CO, CH2, CH3. So 2-butanone is produced. Okay, so just remove CO3 part, the remaining one will be 1, 2, 3, 4. So 1, 2, 3, 4. 4 carbons will be the like thing present in the product. Okay, hope the discussion is clear. Right. Then next, reduction process. So reduction process includes conversion of carboxylic acids to respect to alcohols. Okay, so here we can use lithium aluminium hydride. What is this? We can use lithium aluminium hydride, which converts given carboxylic acid to alcohol. Okay, or we can also use B2H6 in THF, tetrahydrofuran, is a ether, cyclic ether. Okay, next, complete reduction. Yes, we can do complete reduction of carboxylic acid to respect to alkanes by treating that with red phosphorus, like hydrogen iodide. Okay, by heating it with HI with red phosphorus. Okay, at 473 Kelvin. For example, I have acetic acid. Okay, acetic acid upon heating, what happens here? It will form respect to product. Okay, so here see RCOOH is there, giving you RH type of product. Okay, so here you are going to get a CH3, CH3. Okay, like this. This is a product formed. Okay, then next, halogenation. What is this halogenation? Like acetic acid is there now, the adjacent carbon here is called alpha carbon. So on this alpha carbon, if any hydrogen is present, upon treating with bromine in red phosphorus, alpha halogenation takes place. It means one hydrogen here replaced by this bromine. So that gives you CH3, CHBr, COOH. Okay, so alpha halo carboxylic acid is formed. So this is called HVZ, Hell-Vollard Zelensky reaction. Okay, next. Okay, this is important reaction. Okay, it is useful in organic synthesis, particularly for amino acids. We can use this. Okay, you just treat this with ammonia. Now what happens if you treat this with ammonia? You are going to get an alpha amino acid like CH. See, we got alanine here. Yeah, so NH2. Okay, so we got an alanine here. So this is one of the important method. HVZ is important method to prepare alpha halo carboxylic acids, because this can be useful for preparation of amino acids, alpha amino acids like this. Okay, and some other compounds also we can prepare. Okay, so now we have different acid derivatives. Okay, acid derivatives here. See, why we are calling them as acid derivatives? Because if you hydrolyze any of this compound, you are going to get a carboxylic acid. That's why we are calling them as acid derivatives. Okay, so within the acid derivatives, like acid chloride is there, acid anhydrous is there, ester given, amide given. So out of this, which is more reactive, they are asking. So see, acid halides are more reactive than acid esters, then acid anhydrous, the next esters, and least is amides. Okay, this is the order of reactivity. Now if you see, here chloride is there, here carboxylate is there, here alkoxide ion is there, amide is there. So this is the leaving group ability. So based on leaving group ability, you can decide their reactivity order. Okay, right. Second factor is stabilization. Two factors, this order of reactivity explained by leaving group ability and resonance stabilization. Okay. Yeah. So the next, let us see some questions. Yeah. So look at this NEET question. So what question says is, a compound X. I hope the question is clearly visible. Let me check once. Yeah, it's clearly visible. Compound X treated with copper metal at 573 Kelvin. We are going to get A. A is treated with this complex. What is this? This is nothing but a Tollens reagent. What is it? Say Tollens reagent. This is Tollens reagent. Okay, silver ammonical silver nitrate solution gives this complex, giving a silver mirror. It means A is an aldehyde. Maybe A is a aldehyde with 2 carbons, means definitely aliphatic aldehyde. Okay, it will not be a ketone. Okay, it's an aldehyde. Okay, and with 2 carbons there is no possibility for ketone formation. Definitely it will be a aldehyde. A is an aldehyde. Now A treated with OH giving you, under heating condition giving you Y. So definitely this reaction, see, treating with OH minus means this is something called I can say aldol condensation. What is this reaction product? Aldol reaction. Okay, now this A treated with semi-carbazine, it will form a semi-carbazone product. Okay, because A is an aldehyde, right? Now they are asking identify A, X, Y, Z. It's very easy, do not worry about that. Okay, first of all, in order to form this aldehyde, okay, because it is giving a silver mirror means definitely aldehyde, and the starting material contains only 2 carbons, so it cannot be a ketone. So definitely here undergoing oxidation giving you aldehyde, definitely it will be a alcohol. So with 2 carbons, what are the possible things we have? It can be alcohol, a primary alcohol. Okay, so primary alcohol here, just check, X should be a primary alcohol. Yes, here we have ethanol. Okay, here we have ethanol. Yes, here also we have ethanol. Okay, and A should be ethanol upon oxidation give, see, C2H5OH gives you CH3COH, acetaldehyde. Okay, acetaldehyde is A. What is A here? Acetaldehyde. So where do we have acetaldehyde? The IUPAC name of acetaldehyde is 1, 2 now. So ethanol. What is that? Ethanol. Ethanol, this is ethanol. Yes. So here we have ethanol. Yeah, we got these 2 things. A, X. Okay, there is only one option in that way. So yeah, there is only one option. You can directly choose option D as your answer. If you wanted to confirm, yeah, when you react alcohol with this semi-carbazine, this terminal N2 react, NH2 react with that aldehyde gives you semi-carbazone. Yeah, here you have Z is a semi-carbazone. That is perfectly correct. And what about this aldol condensation product? It's easy, right? Acetaldehyde. What it will do? These 2 alpha hydrogens and this oxygen removed as water gives you H. This is the final product. How many carbons are there? 1, 2, 3, 4. So but, okay, but 2 in all, but 2 in all. Yes, but 2 in all. So Y is also perfectly correct. So option D is the best answer for the question. Hope you got this concept and clarity on this question. Okay, so do not worry or do not scare by looking at this many transformations. It will be very easy, and there are many clues if you see all the transformation properly. Okay, see, silver mirror means definitely aldehyde. Okay, and the next is C2. Yeah, so here oxidation product, like that you just go through the clues. Okay, you will get the answer easily. Okay, right. Go through this question once. Match list 1, list 2. Okay, how can we do this? See, it is very easy. Whatever the questions I have picked here, all of them are like PYQs only. Okay, so you just need to take an aldehyde or a ketone, a carbonyl group to be taken. To that we are going to add these things and they are going to form these products. Okay, the names of products is mentioned. So when you are adding HCN, so you should get the product formed is called cyanohydrine. What is this product called? Cyanohydrine. Okay, to this carbonyl group, if you add HCN, you are going to get a cyanohydrine. Okay, if you are adding alcohol, you are going to get for aldehydes it can be hemiacetal or acetal. For ketones, hemiketones. Ketones for ketones it can be hemiketal or ketol. Okay, here they mentioned acetal. Definitely alcohol addition gives you acetal. Okay, when we are going to add primary amines to aldehydes and ketones, we are going to get imines. Imines are also called as Schiff's bases. Alkyl imines here formed is called Schiff's bases. So 2C. Okay, these names are important. That's why I have picked this question. Okay, and when you add hydroxyl amine to the ketones or aldehyde, you are going to get oximes. Okay, what you are going to get? Oximes, D1. Okay, so where do we have such options? A4, okay, B3, C2, D1. So option A is your perfect answer for the question. Okay, so this is how you need to match the list 1, list 2. Okay, it's important. Okay, now the product formed, same, just now I discussed it now, based on the table only you have one more question. It's just one line statement I have used it there. See, the product formed by the reaction of aldehyde with a primary amine. So what it will gives you? A alkyl imine, I told you. What is the name of that alkyl imine product formed? That is Schiff's base, I told you. Yeah, see here Schiff's base, that will be your answer. Okay, how easy it is? And this is also NEET question only. Next, which of the following reagent would be distinguished cis cyclopentadienol from the trans isomer? See, they are saying the structure as a cis. Just write the structure of that cyclopentadienol 1,2 diol. Okay, 1,2 diol. Cyclopenta 1,2 diol. Okay, so this is a cis1, cis isomer. It means both OH groups are same plane, and another one is trans isomer. One OH group below the plane and another OH group above the plane. Okay, see, it is very easy. The best suitable reagent here is acetone. Why acetone? I will tell you. Just now we discussed when an alcohol is added to ketone or aldehyde, it will be forming acetol, ketols, hemiacetal, hemiketols. We discussed, no? So here, if I use that ketone, here, what we are going to get here? If I use acetone, see this hydrogen, oxygen, and hydrogen like removed as water, we are going to get a cyclic form. Okay, so what we are going to get? We are going to get a cyclic ring here. Like this. Okay, so this is possible when both OH groups are lies within the plane or above the plane or below the plane, like they should be in the same plane. That ring formation, the cyclization does not take place if one OH is above the plane, one is below the plane. Okay, because acetone cannot be reacted with this trans one due to the different planes of OH groups. Okay, here within the same plane, yeah, within like both lies in the same plane, so here reaction possibility is there. So acetone is the best reagent to distinguish, okay, this is cis and trans isomer. Okay, hope the discussion is clear. Right, let's move forward. Yeah, so look at this, the products given in the reaction are, so what are the products formed in the given reaction? See, how can you decide this? Aldehyde is mentioned, a chlorine is mentioned, and KOH, 50% KOH is mentioned. Like might be like concentration is mentioned. Okay, now what will be the product? How can we decide this? Okay, here it is easy to decide. Now see, is there any alpha hydrogens in the given compound? No alpha hydrogen, so it is not an aldol condensation. Remove, not an aldol condensation. Next, what is the other possible way? Yeah, here you can see K plus OH minus. Now OH minus ion can also act as a nucleophile if there is no acidic group to abstract proton by this OH group. Now this carbonyl group, I mean hydroxy group, directly attack on the carbonyl group. Okay, what is the reaction called? Cannizzaro reaction. I hope you know this. Okay, so if there is no alpha hydrogen, we can expect for Cannizzaro reaction. Okay, so right, see, carbonyl compound without any alpha hydrogen can undergo Cannizzaro reaction. So it will be forming O minus OH hydrogen here. So the next, this comes down, this hydride shift takes place. So this molecule is there now. By default you should consider 2, okay, because the solution of this compound contains n number of such units now. So if one unit is undergoing oxidation, the next unit takes this hydrogen and undergoes a reduction. Okay, so hydride will attack here and it will be forming O minus H. So you are going to get something like this. You are going to get a carboxylic acid from here, okay, carboxylic acid from here, and a alcohol from here, benzylic alcohol from here. Chlorine remains unreacted like this. So where do we have such option? Yeah, so you can see option D is your perfect answer for the question. See, we got an alcohol and a carboxylate ion. See, these chlorines will not involve in the reaction. Why? Because they are aryl halides, so they won't comes out, because respect to carbocation formed after removing chloride are highly unstable, so it won't come out. So option D is your answer for the question. Okay, right. Will you try this question? Yeah, will you try this once? Anyone in the chat box, please answer me. The product A and B in the following reaction sequence is, see the product here, the pH, see, so what exactly it is? It is nothing but styrene. What we can say, it is a styrene. Okay, like this it will be. Okay, so this is treated with HBr, so it follows Markovnikov rule and gives you bromine here. Okay, and treated with magnesium now. So it will form methyl magnesium, this phenyl, benzylic magnesium bromide here. We got a Grignard reagent here. So this is our product formed after reacting these two things. Okay, this is treated with CO2 gas, carbon dioxide, followed by acidic hydrolysis. We are going to get a carboxylic acid here, because the CO2 is electrophile, this carbon is nucleophile, attacks at this electrophilic center. Okay, OH. Okay, so this is our A. So A is treated with SOCl2, thionyl chloride. This is treated with SOCl2. This OH will be replaced by chlorine. Okay, chlorine, and again it is treated with methylamine. Okay, so you are going to get NHCH3. So this is your final product. So just check the options. Where do we have such option? Yeah. So they are asking about A and B. So this is your B. Where do we have this B? Yeah, here if you see CH3, NH, CO, yeah, this is perfect. And here 1, 2, 1, 2, yeah. So this option C is your answer. If you check, yeah, you will get the clarity. Just check this A, B. Okay, so this is how you need to answer the questions. Do not feel scared by looking at this many transformations. Very easy, simple transformation. You know, you need to practice this kind of question, reaction series questions, in order to get more command over the organic chemistry. Okay, right. Vijay Koppula, hi sir. Hi dear. So are you following the session? Is this clear, whatever we discussed? Right, let's move forward. Yeah, can you solve this question once? Which of the following compound has a largest equilibrium constant for addition of water? It means we are adding water, okay? So it should, see, equilibrium condition means it's very easy. Equilibrium constant means we are adding water. So definitely we know water will attack at this electrophilic carbonyl groups in all of these molecules, right? Like this, like this. So equilibrium constant value should be largest. It means this equilibrium should move forward. The one which is having greater forward reaction has greater equilibrium constant, because what is equilibrium constant formula? So equilibrium constant is nothing but it's a ratio of concentration of products by concentration of reactants. Okay, if the equilibrium is moving forward, it will be having greater numerator value product concentration, that is equilibrium constant value is also greater. So now tell me which is having greater equilibrium constant? The one which is more electron deficient, how greater equilibrium constant? See this is electron deficient now, so it is easy for water to attack at this carbonyl group because of this electron withdrawing groups that makes this carbon more electron deficient, and water attack is easier here. So 3 will be the most electron deficient and it will be having largest equilibrium constant. Like this you need to answer, okay? And few more questions here I am providing. Just tell me what are the answers for them in the chat box, okay, in the comment box. Guys, even if you are watching it recorded later, so I am saying for those who watch it later, this is a live session now. So once who are watching it for recorded also, if you or got the answer, if you get the answer, please mention in the chat box. Definitely I will respond based on your answer, okay? Whether it is correct or not, we will discuss based on your response, okay? So try to answer this, and also these questions and these questions here, all these questions is for you. Just give a practice. All these are very useful. This contains JEE, NEET and EAPCET questions, okay? Right. Hope the session is highly helpful, okay? If you followed this and if you like the content, please click on the follow button and you can share with your friends and just mention your feedback in the chat box. Thank you for watching.